In this video, we'll discuss bond polarity and how to identify the type of bond polarity in a compound. Bond polarity is based off of the electronegativity of the atoms in the compound. Since we're talking about bonds and the sharing of electrons or the donating and accepting of electrons, the electronegativity determines how strongly one of those atoms pulls the electrons compared to the other one. So an atom with a high electronegativity will pull the electrons in really close, where an atom with lower electronegativity won't pull the electrons in as closely. So you have three different types of bond polarity: nonpolar, polar, covalent, and then ionic. In polar covalent, the electrons are being shared evenly. Polar, one electron has a higher electronegativity, so it pulls the electrons closer, creating a negative charge, a slightly negative charge on one atom, and a slightly positive on the other. And then you have ionic, which is where you have a really big difference between the electronegativity in the atoms, and one atom will pull the electron off of the other atom, creating a negative and a positive charge, and the atoms are attracted to each other because of the charge. So if the difference in electronegativity is between 0 and 0.5, that's going to be a nonpolar covalent. If it's between 0.6 and 1.9, that's a polar covalent. And then if it's 2.0 or greater, then it's going to be considered an ionic compound or an ionic bond. And so remember, we have bonding electrons. These are the single ones. So single electrons are considered bonding electrons because, each atom needs a total of 8. And so a single electron would give you an odd number. So you have to pair that up with the electron from another atom. So these are considered bonding, but the ones that have two right here, these are called lone pair. These are not bonding electrons. So here's an example of an analysis. We're going to look at the Lewis structure for CH3F, and we see the electronegativity of each of these atoms. And when we look at the CH bond, we can see that the electronegativity is 2.55 and then 2.20 with a difference of 0.35. So 0.35 makes that a nonpolar covalent. Now let's look at the CF bond. 3.98 and 2.55, that gives us a difference of 1.43. It's still covalent, but this time it's polar covalent. Now, do you consider the compound polar or nonpolar? It's polar. If one of those bonds is polar, that makes the whole compound polar. And the reason that it's polar is because fluorine is very electronegative. That is the most electronegative, the most negative element in this compound. Another example, pH 3. We have a difference of 0.01, so you would think that this would be a nonpolar, right? But we have a lone pair of electrons which are fully negative. They're not being shared, they're fully negative, and it's on the central atom. The key there, the central atom. So this is actually a polar covalent because the lone pair on the central atom, and phosphorus is more negative than hydrogen. Let's look at another example. Silicon and fluorine. Look at this. There's a huge difference, right? It sure does look like it's an ionic compound because of the difference in electronegativity, but because we have a totally balanced, symmetrically arranged particle here, we have 4 fluorines around that silicon, this is an exception. So because of that, it's not going to be ionic. It's going to be nonpolar covalent. Now the first example was pretty straightforward, and the last two were more or less exceptions. So hopefully this video helps out.